Hello friends, how many of you have thought about Google TensorFlow? Well, I know you people definitely know about this term, but what I would like to demonstrate over here is slightly different thing. What is that different thing? Well, first let's see what I have got. I have a reference x which is of type numpy array, and look over here, I have got some numbers over here. Similarly, I have got another numpy array which is y, and over here also there are some numbers. The question is, are these numbers, I mean x, does x has got anything to do with y? Look at the number very minutely. The first number is -1 while y is -3. Then x is 0, then it is -1. It is 1 and it is 1 over here. X is 2, the output is 3 at that point of time. When x is 3, the output is 5. Yes, you have rightly guessed something. Well, y has a pattern, that is 2 into x minus y. So when the value of x is -1, I will put the value 2 into -1, that is -2. -2 and -2 is -3. That's the reason you are getting -3. When x is 0, so 2 into x is 0, is 0, and it is y is -1. Let's think about this one, 3. 2 into 3 is 6. 6 minus 1 is 5, and that is the value of y is 5 and x is 3. But the question is, I know this pattern, you also know this pattern, but in my program over here I didn't write this pattern anywhere. Will computer be able to guess what is the pattern that is working in context to y in regard to x? Do you think a system can predict that? Yes, you rightly heard. I'm saying that, can the system predict that -3 is getting resultant because of this formula or because of this small equation? Can the system identify that prediction? Yes, that is possible, and there where the concept of neural network comes in picture. So with the help of neural network, with the help of Google TensorFlow, the system will able to figure out what is the pattern that is in between x and y. So x is an independent variable, but based on this independent variable, the y is going to generate over here based on this particular pattern. And if you want, the system should figure out this pattern. That means if I give a new number over here, suppose 5, then 2 into 5 would be 10. 10 minus 1 is 9. That prediction should be there. So y would be 9. If I have, give the value 100, so 2 into 100 is 200. 200 minus 1 is 199. That should be the result of y that the system should predict, in spite of the fact that I'm not writing this formula anywhere. And that will be done with the help of neural network. A very simple neural network I have created over here with the help of Keras. Well, Keras is going to come from the Google TensorFlow package, and I'm going to give a call to sequential. Sequential will create a neural network, and I'm going to create only one neural network that will contain only one neuron. Okay, very simple neural network I'm going to create over here, and I'm going to pass on the optimizer as Gaussian descendant. What this is going to find out is that it will tell me that how far I am from the actual value. That means how far the predicted value is different from the real value. So that's what the compilation or the optimizer is going to do. Acoustic Gaussian gradient descent will be figuring out that what is the difference between the predicted value and the actual value. And then I have to train my model, and during the training cell I will be giving a call to epoch over here. The epoch will do the training part over here, and I'm going for 500 epoch. That means 500 times this particular input will be provided. So if you see over here, when it started, at that point of time, the loss function, the actual value is much higher at the initial stage, and when the system would compile the entire process, at that point of time it will generate a much lesser value. Okay, that's how it's going to work. So here I've gone for epoch. I've again mentioned the epoch as 500, and it is I'm going to pass on the x and y variable. So x is this array, numpy array, and y is the output of the numpy array, and based on that this rotation will be going on, a kind of iteration will be going on. From that it will find out what is the actual relationship. Eventually, because of this epoch, it will find out this particular pattern. Okay, and once the pattern has been found out, what I'm doing is that I'm going to, this got stored inside the model. So here the model is going to store this thing, and after model has stored that one, I am passing a new input to find out what is the predicted value over here. Like I have given a value, suppose 10 over here. So 10, 2 into 10 is 20, 20 minus 1 is 19. So if I run my code over here, I would be getting the answer around 18.978, which is very close to 19. So that means system has correctly predicted the actual value. Okay, as you can see over here, the epoch is still going on. See over here, around 500 epoch I have gone. So initially it started. If I scroll down from here, you will be able to see that one. Let me scroll up this one. See over here. So this is how it started. See, from 1 it started, it's going to up to 500, and then I'm giving the actual value. I'm inserting a new value. Suppose I'm going for 10. So the value which it will generate is the following one, 18.99, which is 19, right? So if I go with, suppose a value called 15, 15, so 2 into 5 is 2 into 15 is 30. 30 minus 1 would be 29. So I would be expecting that the value would be very close to 29. See, 28.99 is actually 29. Now what I have to do is that that means my prediction has been very successfully correct. My model has been trained very well. So now I have to write a piece of code, and because of that, I will be able to download this model. Okay, that's the code I've written over here. Okay, here the download of the model will take place. Eventually I will be getting this particular file, and I've given the name of the file as linear.tensorflow Lite. Remember, I'm working on Google TensorFlow, so I will be downloading this particular file after I have saved this model. So once the model has got saved, this TensorFlow, I have created a file by the name called linear.tensorflow. I'm downloading that particular file. Now why I need to download this? Well, you're working on Colab right now. You have created a machine learning neural network with a single neuron that has got one neural network. That is fine, but at the end of the day, how an end user is going to use, and that is the main thing. You have to create this application in such a way so that even like a 5-year-old kid also can run the application, isn't it? That's the beauty of the software development. So for that reason, this particular model I am going to insert inside my Android app. Yes, you rightly heard. Look over here, I have downloaded the TensorFlow Lite machine learning model, and that's what I've kept over here inside the asset folder of my Android. And here I've written a piece of code snippet which is eventually going to give a call to the TensorFlow package of Google, and that's the beauty. So now what I have done is that if I run my application over here, when I'm running this Android application, it will ask me to enter a number, and that number which I will give will eventually be passed into the mapped byte buffer which is coming under the TensorFlow, and TensorFlow will then check out what the number is, and the model already knows what the pattern is, and it will find out the result. So if I pass over here, suppose 25, so 2 into 25 is 50, 50 minus 1 is 49, so the result is going to be 48.93, which is exactly close to 49. That means the model which has been generated, a custom model. The beauty is I have created a custom model. This model I have created, and that model I'm passing it into the Android application, and eventually the Android is now working on machine learning. And that's the reason why Google TensorFlow, which is a very lightweight neural network framework that is so popular in the modern era. Not only that, here you can go and check this particular website called netron.app, where you can pass on. Here you can see that I have actually the TensorFlow file which I've created. I have provided it over here, and here what I'm getting is that I will pass on one input, and that input will go into the neural network, and that neural network will generate one output. And over here I can see what kind of input I am passing. My input would be in the form of an array, which is basically a float type. That's the input which I will provide to my model, and that model, after it has done the computation, will generate one output which is also a double dimension matrix. And fortunately, unfortunately, whatever you say, that's the piece of code which I've written inside this particular function called on create and load model file, and eventually you are seeing this particular program. So let me stop the application once again, and let me run this application again. So this application is directly going to work with my custom model and it is asking to enter a number. Suppose I give easy number, like suppose I'm going for, tell me what number I will go, suppose 42. So 2 into 42 minus 1 would be the result, and that is 83, very close to 83, right? So that means that's how Google TensorFlow package would allow you to create a custom neural network where you will pass on an independent feature. Well, in neural network we call this as independent feature, and this is the output that the feature is based on. So what the neural network will do is it will try to understand what is the relationship between this independent feature with the output that it is going to generate, and based on your data set it will come up with some pattern, and that's how the neural network or deep learning is going to work. And for that reason you need to make use of TensorFlow library of Keras. Okay, so that's all from this video presentation. Surely I will be working more on this. In fact, I'm already working on this, and very soon I will be showing few more application making use of TensorFlow Keras library. Until then, have a nice time. Bye bye.